See, part 1 is the kind of calculation question you can expect to get. So when you look on the O-level concept playlist, there should be a couple of videos on mole calculations where you will see I'm applying whatever I'm trying to do here. There's using fraction, yeah, okay. So I like to work with fraction because I wouldn't go wrong with it. They say you use excess carbon monoxide, so that means the iron 3 oxide is limiting, and that is what we are going to use. So we have that. We want to find the mass of iron. Okay, so that is what we want. So the MR of Fe2O3 is 2 times 56 plus 3 times 16. So I got 160, and the AR of iron from the periodic table is just 56. So the mole of iron over the mole of iron 3 oxide. From the balance equation, it shows 2 mole of iron. 2 mole of iron is produced from 1 mole of Fe2O3 when there's no number in front. Then on the right, I'm going to put in the actual mass of iron that I produce. Okay, divided by the molar mass. That is going to give me the actual mole of the iron. Okay, at the bottom there, I have 14.4 gram of the iron 3 oxide. Again, it is the mass of the iron 3 oxide divided by the molar mass of the iron 3 oxide. Give me the mole of the iron 3 oxide. So the mass of Fe over 56 is 2 over 1 times 14.4 over 160. I would prefer if I rearrange everything before I pop things into the calculator, because it will save me the time and it will save me the effort of having to key into the calculator twice. But it's a personal preference really. So I got that exactly, but I want you to answer to 3 significant figure. As you could see, the data is given to 3 significant figure. So if you're in practical, you should know what is appropriate number of significant figure to leave your answer to. I don't need to put a gram because they already have a unit there. Alright. So now they want the volume of carbon dioxide. They want it in dm cube. So the molar volume of a gas can be expressed as 24 dm cube per mole. It can also be expressed as 24,000 cm cube per mole. This is at room temperature and pressure. Since they want in dm cube, I'm going to be using this for my molar volume to make my life easy. So I'm going to relate it to the iron 3 oxide because I cannot say my calculation is definitely correct, right? So I always use whatever information that I have. So here I want this and I have that. Okay, so I have 3 mole of CO2 from 1 mole of iron 3 oxide. 3 mole of CO2 from 1 mole of iron 3 oxide. On the right, I will have the mole of the gas, but because it's a gas and I'm working with volume of a gas, so the volume in dm cube divided by 24. Volume of CO2 in dm cube divided by 24 dm cube per mole will give me the mole of CO2 with the unit of mole. Okay, at the bottom there is the same as the mass of the iron 3 oxide that reacted divided by the molar mass of the iron 3 oxide. So doing the same thing, so volume of CO2 in dm cube is going to be 3 over 1 times 14.4 over 160 times 24. I have cut down 1 step there, so I assume by this stage you should be alright with this kind of calculation. They did not say 3 significant figure or whatever, they just said room temperature and pressure, so I'm fine leaving that at 6.48 dm cube. Alright. Next bit is asking you on calculation. They want you to work out the mass of calcium carbonate. So the equation is all the way up there. I'm just going to rewrite the equation. You don't have to if you have access to the equation. What was it? Calcium carbonate plus HCl. Give you calcium chloride plus CO2 plus H2O. So that was already balanced, yeah. Cool. So there's carbon dioxide there. It's given as a gas. There's cm cube. The molar volume of a gas. If in cm cube, you can use 24,000 cm cube per mole. You want the mass of calcium carbonate, which is a solid. So you need the MR of calcium carbonate, which if you work out it's going to be 40 plus 12 plus 16 times 3 is 100. So if I do mole ratio, the mole of carbon dioxide, it so happened that here is 1 mole of this reacts with 2 mole of this, is 1 mole to give you 1 mole of this, 1 mole of this, and 1 mole of this. We do not write the 1 mole when we try to balance the equation or write equation, but I'm just showing you that 1 mole of this react with 2 mole of this to give you 1 mole of this, 1 mole of this, and 1 mole of this. Here, 1 mole of CO2 is formed from 1 mole of calcium carbonate. Only because it's 1:1, I straight away can equal them like that. The CO2 is a gas, so volume of a gas, which is 16.8 divided by 24,000, would give me the mole of a gas. Volume of a gas divided by molar volume of a gas give me the mole of a gas. This is a solid. For a solid, the mole relationship is going to be the mass of the calcium carbonate divided by the MR, which we calculated before was 100. So moving that there, you can move the 100 up there. You're going to get 16.8 times 100. 16.8 times 100 divided by 24,000. You're going to get 0.07. But they want the answer to 3 significant figure. So this currently is 1 significant figure. The number in front of a number greater than 0 is not counted at all. So this is only 1 significant figure. So you have to be 0 gram for it to be 3 sig fig. This is a very simple mark that you shouldn't lose, because a simple mistake like that is gonna make you drop that 1 mark. It means you're not careful in reading question. You don't know the idea of significant figure. Test for carbon dioxide. So you test with lime water. So lime water is a saturated solution of calcium hydroxide. So when you add lime water, it's going to give you calcium carbonate, which will be a white or chalky precipitate, and you're going to get water as well. So you get a milky or chalky. In fact, because calcium carbonate is very insoluble in water, it's also present in chalk as well. If you have chalk, so it's insoluble in water, it's a chalky or milky precipitate is formed. Okay. Next bit is a calculation question. So they want the volume of hydrogen. They want it in dm cube. So hydrogen exists as a hydrogen gas, and we talk about molar volume of gas being 24 dm cube per mole. Okay, 1 mole of any gas at room temperature and pressure occupies a volume of 24 dm cube. If they want in cm cube, I would have used 24,000 cm cube per mole, simply because this value and this value, the value are different. That's because of the unit. 1 dm cube is 1000 cm cube. Yeah? They say you use excess sulfuric acid, so you don't need the sulfuric acid, because whenever something is in excess, you never use it for calculation. Why? Because it's not used up. If it is not completely used up, how can you use it to work out how much you will get when it's not even completely used up? Yeah. So this is completely used up, therefore. So you can work out the AR of zinc. Sorry, you don't work it out. You just refer to your periodic table. And zinc shows me a 65 there. So what I'm going to do now is I'm going to compare. All right. Actually, I'm going to write the equation because it's quite easy. Zinc plus zinc sulfate plus sulfuric acid, zinc sulfate plus H2. Zn2 plus, this is a redox. Hydrogen plus 1. I will very quickly go through this because we already went through in the earlier part of the question. Yeah? This is zinc plus 2, that is hydrogen 0. Element 0. Okay, oxidation state 0 because the atoms are in the elemental state. Sulfate anions. You do this in paper 3, you do this in theory as well, so you know it's 2 minus, and the hydrogen is plus 1 there. You know the SO4 is 2 minus, therefore the zinc must be plus 2. The oxidation state of a metal ion is the charge of the metal ion. Okay, this is a redox. Anyway, that equation is balanced. So what do we want? We want this because that's the volume we want. We know the molar volume, so we can connect the molar volume of a gas gas with the volume of the gas to work out the mole. Okay, no problem. But we are given the information on zinc. Since the sulfuric acid, which is concentration times volume, that is in excess, that's not going to be useful for us. So we're not going to do mole equal to concentration times volume because we are not even given this information and it's in excess, right? This is mass because this is a solid, it's a metal. So we're dealing with mass over mR, which is zinc, alright? This equation is balanced. I hope you can see that. Actually, I'll write it down for you so that it's very clear. It's 1:1. Why is it 1:1? Well, the equation is balanced. That's the most important thing. 1 mole of hydrogen is formed from 1 mole of zinc that reacts. Could you have gotten it the other way around? It doesn't matter. If you got it the other way around, it still be 1/1 based on the equation, yeah? Okay, the top bit is represent the mole of hydrogen. So now, that is from the balance equation. Now I'm going to do the actual experiment, okay? These are the actual value. I want the volume of hydrogen gas. I want it in dm cube, so I will divide that by 24, okay? So that is the volume in dm cube. That is dm cube per mole. 24, right? I use 24, that is dm cube per mole. So dm cube and dm cube will cancel. That will give me mole. Mole is the unit here. Mole is the unit here. 1 mole is to 1 mole. Mole is the unit here because it's the mole of H2. So that's why we use the word equal. The symbol equal is a very powerful symbol, and this is just fraction, alright? We're just comparing ratio. So now bottom bit is the mass. So 0.55 gram divided by 65. So that one is just the mole of the solid. The unit there is mole. This is mole. This is mole. So we have not broken any rule at all, yeah? So what I can do is I can show you before I simplify further, although by right you can actually simplify everything one step, okay? 4.55 divided by 65 times 24, that gives me 1.68. The answer will be in dm cube because this is in dm cube because this is in dm cube per mole. If I use 24,000, this will be in cm cube, alright? The thing is, oh yeah, they did specify the unit already. If they don't specify the unit, you got to have the unit there, otherwise it does not have a meaning, yeah? The other thing is you got to look out if the question asks you to run it up to certain significant figure or not, which in this case it doesn't. And this is 1, 2, 3. These are 3 sig fig, and these are 3 sig fig. It's perfectly fine, yeah? Next bit, so in zinc phosphate, so phosphate is PO4 3 minus. You would have seen this in the earlier question when I went through phosphoric acid. I wonder where did I go through phosphoric acid. Nope, not there. There? Nope, not there. Where's my phosphoric acid? Oh yeah, there is. Phosphoric acid H3PO4. You will have come across it when you learn polyatomic ions, whether you are in year 9 or year 10, when you first learn about constructing formula. Okay, so that table is not given, yeah, so you better know your formula of polyatomic ions, yeah, if you want to get correct formulas and do well in chemistry. Okay, so the percentage by mass of zinc. How many zinc do you have? You have 3 zinc, and each zinc has a mass of 65 gram per mole. So altogether the MR of, I'll just write the MR somewhere there. So the MR you can work out somewhere. Just make sure you can key in your calculator very, very clearly. You have 3 zinc, you have 2 of the phosphate. Each phosphorus is 31. Each oxygen is 16. Okay, so put everything in and you are going to get 31 plus 16. Ah, there you go. You see, I made a mistake already. 16 times 4. There are 4 oxygen there. Okay, so 31 plus 16 times 4 times 2 plus 65 times 3. I get 385, but then if I were you, it's very easy to make a mistake when you key in calculator just like that. With any calculation, I would do twice in order to make sure that, you know, that you have done the right thing, rather than sometimes one small mistake can be a huge difference, yeah, okay, between you doing something right or not. So the total MI is 385. You have 3 zinc, so 3 times 65, because 3 zinc altogether in there, times 100%. The usual question really is to find out the percentage by mass of nitrogen. So you want the nitrogen by mass content in fertilizer. So those are the usual thing you have done this kind of question. But I think in recent years, they started to be more creative in asking questions that doesn't involve nitrogen. So, you know, it's the same concept. You just need to know what you're doing, and then you should be all right. So it's blah, blah, blah. But then it depends on, do I want to leave my answer there? I need to think about precision. This comes down to experimental skills. Yeah. So this value I use in my calculation, these are maximum of 1, 2, 3 sig fig. That means if my final answer is 5 sig fig, that is more accurate than what I started with. It cannot be. It started from something which has an accuracy of 1, 2, 3 sig fig. My final answer cannot be more than that. It can be 2, it can be 1, but 1 is probably too little. So I'll keep it to 3 sig fig. The unit is percentage, so they even give you the unit there already. This is 3 sig fig. But I do not simply run out something without writing the value before I run it up, so that I can show, the examiner, if they accept it, if they don't accept it, it's up to them. But I show that I don't run it up straight away. Okay.